In this video, we will understand what is meant by an annuity, what are the different types of annuities, and how to find the future value of an annuity. So, an annuity is a series of equal payments made at fixed intervals for a specified number of periods. So, let's go over the definition again. So an annuity is a series of equal payments. So the first key term is equal payments made at fixed intervals. So the next keyword is fixed intervals. So let's say you are making a payment of 1,000 rupees every time. So equal payment, so the installment is 1,000 rupees, and you are making this payment at fixed intervals. So you can say that this could be monthly, quarterly, yearly, etc., etc., for a specified number of periods. So specified number of periods. So basically you know for how long you are making these payments for. So it could be for 36 months, or it could be 12 quarters, or it could be 3 years, and so on. For example, if you invest rupees 100 at the end of each year for the next 3 years, it is known as a 3-year annuity. So let's say this is the time scale. You have 0, 1, 2, 3. So these are years, and you decide to invest 100 rupees at the end of each year. So this is the first year. So here you are depositing 100. At the end of second year, again 100. At the end of third year, again 100. Now sometimes, since these 100 are cash outflows from your pocket, sometimes people represent this as negative. So this is going out. But as long as you understand that this is outgoing or investment that basically you are doing, we are fine. So this has equal payments, that is 100 rupees, fixed intervals, that is at the end of every year, and specified number of periods, that is for 3 years. So this is known as a 3-year annuity. Now here we consider that the payment is done at the end of each year. So in that case, the annuity is called an ordinary or a deferred annuity. So this type of annuity is ordinary or deferred annuity. For example, payments on mortgages, car loans, and student loans are typically set up as ordinary annuities. Now, if the payment is made at the beginning of each period, the annuity is an annuity due. So the type or the name is known as annuity due. So let's see that. So this is 0, 1, 2, 3. Now let's say we were giving the payments at the beginning of the period. So this is the first year. Beginning is this line here. So this is where we made a cash outflow or an investment of 100 rupees. Then again at the beginning of the second year, we invested 100 rupees. And at the beginning of the third year, again, we invested 100 rupees. So this is also a 3-year annuity. However, the type is annuity due. So this is the name of this annuity. Now some examples are rental payment for an apartment, life insurance premiums, etc. Now typically the ordinary or deferred annuities are more common in the finance world. Now let's look at these two types of annuities in more detail. So let's first consider ordinary annuity, and let's take an example to understand this in detail. So suppose a sum of 100 rupees is deposited in a savings account at the end of each year for 4 years at 6% interest. Find the amount received at the end of the 4-year period. So let's draw the time scale. This is 0, 1, 2, 3 and 4. Now a sum of 100 rupees is deposited at the end of each year for 4 years. So this is the first year. So here we have deposited 100 rupees. Again 100 at the end of second year. Again 100 at the end of third year. And again 100 at the end of fourth year. The interest rate is 6%, and this is the same for each of the years. So the amount of 100 rupees deposited at the end of first year will grow for the next 3 years. So this time frame here, then this time frame here, and then this time frame here. So this amount will grow for the next 3 years. The 100 rupees deposited at the end of second year will grow for the next 2 years. The amount deposited at the end of third year will grow for 1 year. And the amount deposited at the end of fourth year will not have any bearing on the interest accumulated. So this amount 100 will remain as it is and will not yield any interest. So now let's calculate the values of these investment. So first we'll take this 100 rupees, which is going to grow for the next 3 years at 6% interest per annum compounded annually. So 100 is the amount. 1 plus r by 100. R is 6 by 100 to the power n. So this n is 3 years, because this 100 will grow for this year here, then this year here, and then this year. So 3 years. Now what is this? This is basically nothing but the formula for compound interest. So A is equal to P1 plus R by 100 to the power n. R is the rate of interest per compounding period, and n is the number of compounding periods. P is the principal amount, and A is the final amount that we get after n compounding periods. So this becomes 100 into 1 plus 0.06 to the power 3. So this is 100 into 1.06 to the power 3. So this becomes 100 into 1.191, and this is equal to 119.1 rupees. So basically this 100 rupees deposited at the end of first year will become 119.1 rupees at the end of 4 years. Now let's take the amount of 100 rupees deposited at the end of second year. So 100 into 1 plus 6 by 100 to the power 2, because this will grow for the remaining 2 years. So now we have 100 into 1 plus 0.06 to the power 2, 100 into 1.06 to the power 2, 100 into 1.1236. So this is 112.36 rupees. So this 100 rupees deposited at the end of second year will now become 112.36 rupees. Now let's move to the third investment of 100 rupees. So 100 into 1 plus 6 by 100 to the power 1, because this is invested for the next 1 year, equals to 100 into 1 plus 0.06 to the power 1 equals to 100 into 1.06 to the power 1 equals to 100 into 1.06, which is equal to 106 rupees. So this is 106 rupees. Now let's move to the fourth investment of 100 rupees. So 100 into 1 plus 6 by 100. Now this is at the end of the 4 years. So the time frame for which this is invested is 0 years to the power 0. So 100 into 1 plus 0.06 to the power 0. 100 into 1.06 to the power 0. Now anything to the power 0 is 1. So this is 100 into 1, which is 100 rupees. So this is 100 rupees. So at the end of 4 years, the amount of money received will be the total of all of these, which is equal to 437.5 rupees. So basically how we got this was by calculating the compound interest on each of the investments for this annuity. So basically what we did is the future value at the end of 4 years is equal to a into 1 plus r by 100 to the power 3, that is this one here. So a is the amount of annuity installments, which is 100. 1 plus r is 6 to the power 3, plus a into 1 plus r divided by 100 to the power 2, plus a into 1 plus r by 100 to the power 1, plus a into 1 plus r by 100 to the power 0. So this is what we did. Now let's consider r by 100 as I. So 6 by 100 can also be written as 0.06. So that is I. So this is equal to a into 1 plus I to the power 3 plus a into 1 plus I to the power 2 plus a into 1 plus I to the power 1 plus a into 1 plus I to the power 0. Now let's consider 4 as n. So instead of 4 years, let's generalize this. So if it is an annuity for n number of years, what will this look like? So the future value of an annuity at the end of n years will be equal to, so here we had future value at the end of 4 years, and the formula was a into 1 plus I to the power 4 minus 1. So here this becomes a into 1 plus I to the power n minus 1 plus, now the second term was a into 1 plus I to the power n minus 2, that is 4 minus 2, and then 4 minus 3, and so on. So a into 1 plus I to the power n minus 2 plus a into 1 plus I to the power n minus 3, so on, up to a into 1 plus I to the power 0, and 1 plus I to the power 0 is 1, so we leave it at this. Let's say this is number 1. Now let me delete this portion here to continue with this equation. So this is the equation that we obtained. Now let's multiply the left hand side as well as the right hand side with 1 plus I. So multiply both the sides by 1 plus I. So then we get 1 plus I into FVN is equal to, now we know that 1 plus I to the power n minus 1 into 1 plus I can also be written as 1 plus I, because the base is the same, to the power n minus 1, which is this n minus 1, and then this is to the power 1 plus 1. So then minus 1 plus 1 gets cancelled, so this becomes 1 plus I to the power n. So basically we can add 1 to these power values. So a into 1 plus I to the power n, because this will become n minus 1 plus 1, because we are multiplying the entire right hand side by 1 plus I, plus, now again we'll multiply this term with 1 plus I, so this becomes a into 1 plus I to the power n minus 2 plus 1, that is n minus 1, and so on, plus a into 1 plus I. Let's say this is 2. Now let's subtract 1 from 2. So let's subtract 1 from 2. So basically this will get a negative sign. Each of these terms will get a negative sign here. Now the left hand side will become FVN into 1 plus I minus FVN. So FVN 1 plus I minus FVN is equal to, now a into 1 plus I to the power n will remain as it is, because this term is not in equation 1. So a into 1 plus I to the power n. Now a into 1 plus I to the power n minus 1 and a 1 plus I to the power n minus 1 in both these equations will get cancelled. Similarly, all the other terms will get cancelled. This will also get cancelled. However, a will remain as it is, because a is not there in 2. So this is minus a. So this will be minus a. So, or let's open this bracket. So 1 into FVN is FVN plus I into FVN. So I FVN minus FVN is equal to a into bracket 1 plus I to the power n minus 1. So FVN and FVN gets cancelled, or I into FVN is equal to a into 1 plus I to the power n minus 1, or FVN is equal to a into 1 plus I to the power n minus 1 divided by I. So this is the formula for finding out the future value of an ordinary annuity with I as the rate of interest and n as the number of compounding periods. where A is the amount of money being deposited on a regular basis. So now let's use this formula for this example and see if we can get the same answer here. So here A is the amount of money being deposited on a regular basis. So A is equal to 100 rupees. I is the rate of interest, which in this case is 0.06. N is the number of compounding periods, which in this case is 4 because it's a 4-year annuity. So 4. So let's plug in these values in the formula. So FV, that is the future value, is equal to 100 into 1 plus I is 0.06 to the power n, which is 4 minus 1 divided by I, which is 0.06. So this is equal to 100 into 1.2624 minus 1 divided by 0.06. So this is equal to 100 into 4.375, which is equal to 437.5 rupees. So this is the same as what we had gotten earlier, 437.5 rupees. So this is the formula to use when we have to find the future value of an ordinary annuity.